with a couple of mathletes, people that I work with individually. And they were older kids. They were like in 8th grade or whatever. And they noticed something really amazing. They noticed that when you look at a multiplication table, and let me just get rid of that, hide it, and highlighter. And let's say we choose the number 12. Can you guys please highlight on your page 1 all 6 of the 12s on that chart? Can anyone make an observation that might mirror the observation that was made by my 8th grader? What observation do you see in looking at this multiplication table? And where I highlighted all of the 12s. Go ahead, Andy.
It's a arc, so it goes from one corner to the other corner, and it goes 12 to each 12.
You know what, Andy, that's a great observation. Everybody look at my hand. Do you see this part of my hand right here? It's kind of the part of my hand which is like the most plump. You can call it the fatty part, but I use this as the center of my compass, which means that when I make a curve, I put this part on the paper and I use my pencil and I sweep, and it works like a compass. So can you all do that and create an arc through all the 12s? And it's quite a beautiful arc. Now, can we do the same thing with another number? Who's going to pick another number for us? Go ahead, Adalia.
22. Actually, no, 24.
Yeah, you know, it's interesting, guys. Before we do 24, mark the number 22 and realize that it doesn't really make an arc because there's only 2 of them. I'm really glad, Adalia, that you chose that one, because that shows a number that only has 4 factors: 1 times 22 and 2 times 11. So let's now choose 24. And 24 is really awesome. Can anyone tell me why 24 is more awesome than 12 in the context of what we just did? Why is 24 more, you know, if a number can be more awesome than another number, why is 24 more interesting? By the way, how did it work out using your hand as a compass? Did that work out well for you?
Not for me.
Well, you have to practice. Remember, I've been doing this for 50 years, using my hand as a compass.
That is a lot of time.
By the way, guys, I've also done it with my elbow, where my elbow is the
that
center.
sounds hard.
Now, watch this, guys. I'm going to back up here. Do you see how my pencil now makes a perfect circle?
Mm-hmm.
So I've done that on big blackboards where I've been able to draw almost perfect circles just using my elbow. Now, sometimes I have fun. I put a screw into some wood and I tie a string, maybe like 3 feet, and I tie a pencil to the string, and I use that as a radius and a compass. And you can make perfect circles that way, but don't screw anything into your wall without your parents' permission. Now, I asked you a question, no one's answered it. Why is 24 way cooler than 12? In fact, it's 25% cooler.
Because 12 plus 12 equals 24, or 12 times 2. And
I agree with that. In fact, actually, may I point out that Alexander's observation is a pretty amazing one. If you look at 2 times 12, which equals 24, that's a pretty cool observation. But guys, what numbers are missing on this red, on the green arc? There's a factor pair that's not there. And it's not there because our multiplication table is not big enough. Hannah, can you tell me what's missing? Cameron?
24 times 1.
Yep. So guys, the 24 has one more factor pair. Now, some of you have learned my factor method before. It doesn't hurt to learn it and use it over and over again. So this is the Kramer factor method. I developed it over years because I hated doing guess and check. So when I factor the number 12, everybody write that down on a separate piece of paper. And then what you should write down on the left is the word double. And on the right, the word half. Now, every number always has factor pairs of 1 and the number itself. So we say 1 times 12 equals 12. Go ahead and say that out loud.
1 times 12 equals 12.
Okay, now quickly double and half. Go.
2 times 6 equals 12.
And the dog was even able to do it, which is awesome. Now, are you ready? Do it again. Go, John. John, you do this one.
4,
3 times
No. Double and half.
4 times 3.
4 times 3.
There you go. You see, the 3 times 4, that's the guess and check method. You just kind of keep going and you add numbers, but people forget numbers all the time. Now, believe it or not, in my last class, a student was able to find all 60 factors of a 4-digit number. And I will give you that challenge later on. But let's first factor the number 24. Oh, and by the way, if you're a great mathematician, you're going to write out the word double and half. Did everybody get 8 factors? Omer, did you get 8 factors? Omer, I can't hear you.
Yes.
Excellent, excellent, excellent. Now, did anybody hit any roadblocks? There were no roadblocks. In fact, if the number on the right bottom is a prime number, we know that we're done. Because the only prime numbers here were 2 and 3. Did we have a prime number here? Yes, we did. Now, would you guys like to see a roadblock problem? Are you ready for this? The first roadblock problem I'm going to give you is a pretty simple one. I want you to factor the number 18. Remember, all great mathematicians will write out, and I'm not going to write it out for you. I want you guys to write it out and see what happens when you hit the roadblock. Okay, so Hannah, would you share with me your factor pairs, please?
1 times 18,
Perfect.
2 times 9,
What did you do with that roadblock?
2 times, but 2 times 9 equals 18.
It does, but it's a roadblock because you can't do 4 because 9 halves is not a factor. Did anybody hit a roadblock at 9? Yeah? And guys, do you know that 1 times 18 and 2 times 9 and 4 times 9 half, they all equal 18? What about 8 times 9 quarters? Is that 18? What about 16 times 9 eighths?
1.25.
Is that 18?
Mhm.
Guys, could we keep going till infinity here?
Yes.
But
Why did you get really
none of
tight?
these would be factors. So what do we do with the roadblock? What numbers are divisible into 9, guys?
2.
3.
Only 3 times 3. So the number that we use next is 3, and we say 3 goes into 18. How many times?
6.
And that is the last factor pair. So 18 is kind of unusual because when we do double half, double half, double half, we actually can't do it here. Now I'm going to ask you all to factor one of my favorite numbers, which is 60. So use my method and use the same method to get around the roadblock. So let's do it out loud. Go. 1 and,
1 and
60.
60.
okay, go. Omer, go.
2 and 30.
Okay, wait. Hold on. We had 2 and 30 from someone else. Omer, you do the next.
4 and 15.
And Isabella. Remember, 15 is 3 times 5. So Isabella, what number goes here next? You have to choose one of these.
5 times 6.
No, you have to choose one of these two numbers and you should choose the smallest. 5 times 6 equals 30. So you're choosing the number 3. 3 goes into 60, guys. How many times?
20.
20.
And double and half, go.
6 and 40.
Half,
40.
half.
10.
Come on, you know 6 times 10 is 60. And double and half.
3 and 12 and 5.
It's 12 times 5, and you would be correct. Since 5 is a prime number, we are completely done. If you found 12 factors of 60, you nailed it. If you tried to do this with guess and check, I guarantee you would miss a few of these factors. Now, does anybody have any trouble doing short division? So for instance, if I challenged you to factor the number 320, how would we get half? How would we get half of 320? Who knows how to divide using short division? So Cameron, take me through it.
And
Yeah, go on a different one.
So 2 goes into 3, how many times? Come on. How many groups of 2 are in 3?
1.
1, and what's the remainder?
1.
Okay, so we write 1 at the top of 3, and we carry this remainder, and we put it next to the 12, or the 2, to make a 12. Now we say 2 goes into 12 how many times?
6.
And 2 goes into 0 how many times?
0.
And that is half of 320. So the next factor pair is 2 and 160. Who can do the next one? Let's do John. Come on, John, double and half, double and half.
4.
Come on, 4 and, come on, take your 160, divide it by 2. 2 goes into 16. How many times?
8.
And therefore, 2 goes into 0, 0. So
80.
80.
80. Great. Go, Alexander. Go, Alexander. And you have to unmute yourself. Keep yourself
6.
unmuted. No, come on. Double
not
4 is definitely not 6.
Double 4 is 8.
Keep going.
40
So you say 8 times
times
40
40.
equals 320. Okay, Andy,
16 times 20.
Adalia,
32 times 10.
and Omer.
64 times 5.
And Isabella.
Can't do anymore.
And
Okay.
that is one of the most important things is that you know when we're done. Is that you know when we're done. Okay, I want to now challenge everybody to tell me a story about this one. Go to page 3. And can you explain to me why there seems to be 2 opposing curves to this one? We have the factor pairs of 12. So we have this coordinate is 1 comma 12, 2 comma 6, 3 comma 4, 4 comma 3, 6 comma 2, and 12, 1. And that makes a lovely curve, which you know that you love this beautiful curve. What is going on here? Why is there an opposing curve? And what does it mean? And you guys can make conjectures. Cameron, what's your thought?
Is that it's the same thing, but with negative?
Can you explain, please? Like take any example that you want.
It'd be -1 to -12.
Guys, -1 comma -12. Because -1 times -12 also equals 12. Awesome. Omer, can you do another one? Give me the coordinates.
-2 times -6.
How about amazing? And Isabella?
1.
Well, one's over here. Come on, if Omer said that this was, say again?
-4. Oh.
Ooh.
-4 to -3.
Very nice, but there's one missing in between, John.
Oops.
-3, -4.
And then Adalia
-6, -2.
and Hannah. Hannah?
-12 and -1.
Yep. And who can give me the rule when you multiply negatives? 2 negatives. Who's got the rule? Andy? Andy, do you have the rule? When I multiply a negative times a negative, Andy, what do I get?
A negative?
Does that look like a negative number?
No.
So what's the rule, Alexander?
The rule is
A negative times a negative is
a positive.
right. So if we're trying to find the factor pairs of 12, we can do it in 4 quadrants. Now, who knows what these curves are called? They have a special name. And the actual graph here is actually y equals 12 divided by x. So if you went to a website called Desmos, or you had your own graphing calculator, actually, you know what? I should do it right now. I should go to y equals, and I should write in 12 divided by x, and I should hit graph. And look at this, guys. Check it out. Isn't that cool? It makes a hyperbola. So I'm going to write out that word for you. Hyperbola. Can you say it?
Hyperbola.
Can you say it with your hand under your chin so you know how many syllables it has? Ready? Hyperbola. You will see your chin, your hand.
Hyperbola.
Hyperbola. Hyperbola. Really kind of neat word.
Hyperbola.
Yeah. Now, it's fun, guys, to look at these for so many different numbers. For instance, on a 20 by 20 multiplication table, what do you think would be a really cool number to see the hyperbola?
20?
20.
20 is beautiful. Why don't you guys go to page 2 and do it? Because I shouldn't have all the fun here. I love making hyperbola. And Andy was the first one that told us about that curve. And remember, use your radius. Remember, you're sweeping your hand around, which is kind of cool. A lot of times there's a lot of sports where we have to use our wrist. How many of you play tennis? Any tennis players?
Play tennis.
How many of you play golf? Golf?
My dad wants me to do golf, but I don't want to do golf.
What? Look at golf. When you do golf, it's all about the wrist. When you play tennis, it's all about the wrist. When you throw a football, it's all about the wrist. When you throw a baseball, guys, the arm means nothing. If you ask any pitcher, it's all about the wrist. And frankly, in mathematics, I also think it's all about the wrist. Am I missing any sports that are wrist oriented?
Lacrosse is. You gotta
Oh.
throw it with your thing.
You know what, guys? Look at lacrosse.
Basketball is too, to throw the ball.
You know what? I can't believe I forgot basketball. Basketball is all wrist. Very little arm.
And volleyball.
Hockey.
And badminton.
Oh, wait.
And hockey. Go get to flick
hockey.
it.
Yes, guys, hockey is just the same. Lacrosse,
99% of sports use your wrist.
you know what?
Except for soccer, the only soccer where that is considered a handball.
What about goalie for soccer?
Yeah.
Oh man, I agree.
And throw-in.
Goalies definitely use their wrist.
Also for throw-ins.
And guess what?
And field
Even
hockey too.
when I used to play soccer, I would pick up the ball and I wasn't even the goalie. They used to throw me off the field, but hey, I still picked up the ball. So anyway, so
What?
guys, who has a better number for us to work on?
60.
Oh,
Well, 60 we did, but let's do it anyway. Come on. Where are my other 60s?
Right?
There's
There's
one.
one right there. Right.
Yeah, you missed one. You missed
I,
one.
you missed one.
But you
There,
have to
there,
say
there.
it.
No.
Yes,
Right
yes.
there.
There,
No.
next to, no.
No,
There,
no.
there. Yes,
There.
yes, yes.
6 times 10. Just say 6 times 10. So you don't have to yell. The beauty of geometry is that
Oh,
you,
you missed another one.
you can just point
20
out
times 3.
20 times 3 is correct. And 4 times 15, 5 times 12, 6 times 10, and all of the turnaround facts. Let's make the curve. Come on, guys, use your wrist.
Mine isn't that big. It's like super small.
Yeah, because I had so many pages. I got a little carried away this week. Sorry about that. Would you guys like to factor a really big number now?
Yeah.
Okay, now, if you do this, we're gonna do it as a team, and we're gonna be team factors. So we're gonna call it the factor team. And we're gonna factor the number 10,000. Now, does anybody have a conjecture as to what the last factor pair will be? So you're going to do all these factor pairs, and at the very end, you're going to have the final one. John, what is your thinking about?
5.
Well, you have to give me 2 numbers because it would be something times something.
I'm actually not sure.
All right, Cameron, what about you, buddy?
actually, never mind. I was gonna say 2 times 5.
Well, 2 times 5 doesn't equal 10,000, so I need a factor pair of 10,000. Dahlia?
2,000 times 5,000.
5,000 times 2.
That is definitely going to be one of the factor pairs, but not the last one. It's the last one that I'm wondering about. Say it out loud, guys, if you've got an idea. All right, guys, I have a challenge for
10,000
you.
times 1.
Say again.
10,000 times 1.
That's the first one. Now, are you guys ready?
5.
Guys, watch me.
5 or 5 times.
In order to lead you to the answer and not give it to you, we're going to factor 36 right now. Go. 1 and 36.
136, 2
2
and
12.
18.
4 and
9.
8.
9.
and
Okay,
9 is
9.
3 times 3. So 3 and
3 and 6.
12.
12.
double and a half.
6.
6 and 6.
6.
Double and a half,
12 and 3.
12 and
12 and 3.
which is a repeat.
Yeah.
So guess what, guys? 6 times 6 was the last factor pair of 36. What's the last factor pair of 4? 1 and 4.
1 4, 2 and 2.
And 2.
Now, back to 10,000.
5
5
times 2,000.
5
Guys,
times 5.
5,002.
10,000
5,000 times 2.
10,000 is a square number. It'll be the square, guys. It'll be the 2 times 2 or the 6 times 6 of 10,000.
500 times 500 then. I'm pretty sure.
That would be
I
20,
mean, no.
that would be 250,000. Too
I
big.
did that wrong.
No, but I like where you're going. I like where you're going, Isabella.
I missed.
50 times 50.
That is 2,500. I like where you're going, Cameron. Come on.
5 and 5.
Okay, let me ask a more pointed question. What is the square root of 10,000? What is the square root of 36? 6. Square root of 4? 2.
4.
What's the square root of 10,000? What number times itself equals 10,000?
5,000? No.
5,000 times 5,000 is 25 million, Adalia.
1.
1 times 1 is 1. I need a number multiplied by itself to equal 10,000.
10.
Omer? Omer, say it again.
100.
Absolutely. So the last factor pair is going to be 100, 100, but don't take my word for it. Let's attack. Are you ready? 1 and 10,000.
10,000. 2 and 5,000.
And that's the one that Andy just came up with. 4 and
2,500.
2,500.
8 and
And
1,250.
250.
16 and
1. No.
stop.
500.
Stop.
5.
Everybody stop, please. 2 goes into 12 how many times?
0.
2 goes into 12.
12.
2 goes into 5.
2.
Remainder 1. 2 goes into 10.
5.
5.
Now, we have now hit our first roadblock. What number do we know goes into 625? Andy, unmute yourself, please. What number do we know goes into 625? Say it out loud.
5.
5.
5 goes into 10,000. Come on, 5 goes into 10.
2.
2,000.
Yeah, 2,000.
Go.
10
and
1,000.
Keep going.
10,000.
20 and
20 and 5,000.
500.
Keep going.
40.
40 and
250.
50
And
80
8
and
Times
and
1,025.
125.
now, roadblock number 2.
5.
We haven't quite gotten to 100 and 100. We know that 5 goes into that, but we've already used up our 5. What other factor goes into 125?
25
25.
25 and what?
and
5.
Yep.
5.
25 and 5.
25 goes into 10,000.
5.
Come on. 25 goes into 100.
5.
4.
Or
0, 0.
Yeah.
Thank you. So there we are, 400. By the way, I'm maybe going to need more room here. And keep going.
50.
50.
50 and
200.
200. 100 and 100.
And
Oh
100.
my God, I can't believe I put it in the right place. That was totally by chance. And ladies and gentlemen, why is that the last? Why can't we keep going? Who knows why? Go ahead, Isabella.
Because you,
Did you say it would be a square number?
well,
Why? But what if we keep going?
because you would
And it
do
would
the
be-
same number again. You would double the same number.
So guys, we
250.
already have 200 times 50 right here, and we are done. Now, you guys just found, this is actually a challenge question. How many factors does 10,000 have? So nobody say it out loud. Everybody figure it out, and I'll call on you in a second.
Wait, 10,000 or 20,000?
10,000.
Okay.
and tell your dog he's wrong.
Random dog over there. You're wrong.
So guys, on 3, 1, 2, 3, go.
24.
4.
26.
46.
26.
26.
Neither of you are correct.
Wait, what?
None of you are correct.
13.
There are 13 factor pairs, but there are not 26 factors.
Is it 25 then or something?
And why
Oh, because
25?
10,000
We
is
were
Because
all
10,000
one
is
away.
not one of them.
10,001.
Because 100 is
Also,
Oh,
yeah.
100 and 100. Yeah.
Yeah.
now listen to this. Every square number is going to have an odd number of factors. Don't take my word for it. Let's look at 36. How many factors has 36? On 3, 1, 2, 3, go.
6.
Not 6.
9.
9.
There are 9. Come on, you've got 4 factor pairs plus the 6. How many factor pairs has 4?
3.
3. Every other number has an even number of factors. Now, here is the big challenge that I don't know if anyone can do it. There is a very special number that was studied by Plato in the 400 BC era of ancient Greece. Now, ancient Greece was on what's called the base 60 number system. And that's why we have our clock. Our clock is from a relic from the base 60 number system. When Plato was alive, they knew that there were 6 other planets in the solar system. Are you with me?
Yeah.
But didn't people not stop thinking that the world was flat until many years after Plato lived?
That is true, and we don't know if Plato believed it was flat, but what we do know is that Plato knew that there were 7 planets.
But some people didn't think that was true.
But Plato did. And so let me explain. Since there were 7 total planets, so Plato asked this question: how many different ways can the 7 planets be ordered in the sky? And the way he was able to answer that is with some pretty cool mathematics. Are you guys ready? Who can tell me what 7 factorial is? Not the answer, but what does it mean? Omer, are you studying this? Are you thinking about it? So what is 7 factorial? And I'm going to write that out. And Dahlia, you're going to tell us what you think.
Wait, what?
It's called well, I saw you raise your hand. Factorial. Go ahead, Adalia.
1 times 2 times 3 times 4 times 6 times 7. No, I skipped 5, I think.
And that, everyone, is the number of ways that 7 planets can be ordered in the sky. Now, everybody go ahead and figure that out. And after you do, I want you to begin factoring that number. Do you know why? Because it has 60 factors. Not 1, not 10, not 25. It has 60 factors. And one of my students in my last class, a 4th grader, was able to do it. Pretty amazing. I'll tell you what 7 factorial is in a minute, but I want everybody to try. And if it were me, I would multiply 6 times 7, 4 times 5, and 2 times 3, and then multiply those products together. I would first do 42 times 6, and then that answer times 20. I'm going to go to the restroom. I'll be right back.
Oh, how are you guys?
All right. Did you guys come up with 5,040?
Yes.
Okay. So I will begin factoring 5,040. You should have already begun. It has 60 factors. And you're going to need a lot of short division here. If you have a problem with a particular short division, ask me right now, because it'll be awesome if we can get to the bottom of it. So I'm going to write my first one out here, 5,040 divided by 2. And I'll show you all the steps. Now, even though I can do some of these in my head, I choose not to because I know that I make mistakes when I do math in my head. And I don't want to make mistakes that are avoidable.
Somebody keeps getting like mentioned or something like that on Google Hangouts. I can always hear somebody's
Hey,
when they're unmuted.
Alexander, I love your comment, but in a different context. Okay? Thank you. I didn't mean to cut you off, but I want to keep it real. Nobody has asked me a question yet. I'm surprised. Maybe you guys are already masters of all of these concepts. Oh, by the way, what factor did you use for 315?
20.
Did you guys add the digits? If you add the digits of a number and it's a multiple of 3, we know that 3 is a factor of that number. So now I go to 5,040 divided by 3. Are you guys okay if I do the next one in my head, 1680? Because 16, half of 16 is 8, half of 8 is 4. That one I think I can do. But remember, there's always risk when you do the work in your head. How many of you reached 105? Hannah, did you reach 105?
I'm getting there. I'm almost there.
Good, good.
I know I will.
What do you think I should do when I hit 105? Because I can't use 3 again. So what number should I use? What definitely goes into 5, guys? Go ahead, Isabella.
5.
5. Excellent,
5.
excellent, excellent. And I'm going to do my division again. And by the way, if you become a master of factoring, by definition, you become a master of factoring, of division. If anybody has a question about the one I just did, because there's something a little interesting there, I would love for you to ask it. What's the next factor, guys, for 63? What goes into 63? What am I using? Come on, what times what is 63, guys? You know your multiplication table.
9 times 7.
There you go. So 7 times 9, I am going to use 7. Critical, critical number. I don't agree with the dog. And
I don't agree with the dog. You really know how to speak dog?
absolutely. Are you kidding? I've been practicing for years, Alexander.
I have tried to speak dog. It doesn't work very well.
No, they're brilliant. Can you imagine an entire species getting an entire other intelligent species to clean up when they go poop? Can you believe
Well,
that dogs, can you believe that dogs have accomplished that? And to me, it's the most amazing accomplishment. If aliens came to our planet, they saw what we did with dogs, they would go to the dogs and know that dogs were the superior species. Because if we clean up their stuff, well, clearly the dogs must be superior. That's just one theory.
the dogs also give us their food, make us pet them, and they hate it. They are superior to us, but sometimes we can reject when they want to do things, such as not wanting to take a bath. They reject that, but we say no, it is good for them. and we obviously want to take care of our superiors.
But also, Alexander, think of infants, babies. There are not many differences to adults. In any event, guys, how many of you got pretty far in this process? I'm gonna leave you to get the rest of the factors, and I want to leave you with one thought. Can you all stop right now? When you hit a wall and you think you're done, start multiplying all of the prime numbers together, like 2 times 3 and 2 times 5, 2 times 7, 3 times 5, 3 times 7, 5 times 7. And if we're missing any of those factors, that will help you keep going. If you guys understand, take the prime numbers, multiply them in pairs, and you will find any missing factor. So I am going to stop sharing. You guys were amazing. I hope you have fun drawing parabolas, and say goodbye to the greatest mathematicians on the planet. And remember, the next time you look up at the sky, remember that we have now 9 planets known. And if you do 9 factorial, it's a much bigger number. In fact, it's 5,040 times 72. I leave
Also remember when
you
you're
with that thought. Ladies and gentlemen, I must go. I am sorry I must cut you off, but I need to go to another group of mathematicians. Be well. Goodbye.